infectious diseases, research, medicine, health. Welcome to Outbreak News Interviews. And now, broadcasting from the Outbreak News Skylar Studios in beautiful West Central Florida, here is your host, microbiologist and editor of OutbreakNewsToday.com, Robert Harriman.
To continue in our discussion of Legionnaires' disease and Legionella bacteria, I have two fantastic guests on today. First, I have Dr. Marc Edwards. Dr. Edwards is a civil engineering, environmental engineer, and the Charles P. Lunsford Professor of Civil and Environmental Engineering at Virginia Tech University, and he's an expert on water treatment and corrosion. And in addition, I also have scientist and engineer Sarah Ferrari. Sarah is also the co-author of several documents and other types of information concerning Legionella and building water systems. And she is also a member of the Alliance to Prevent Legionnaires Disease. It's a coalition of experts that promote best practices on Legionnaires' disease prevention. Dr. Edwards and Sarah, welcome to the show.
Thank you for having us.
Do I have you both? Excellent. Okay, well, let me go ahead and start with some of the questions, and I'll start with you, Sarah, and we'll really start with some of the basics, and just to give my audience, which is probably a lot of lay people, it's not all experts, and what is Legionella, and where is it found?
Well, Legionella is a bacteria that's found in water and soils naturally. It occurs in very low concentrations in the environment. And so generally, out in the world, it's not an issue. Would you like me to tell you how? Well, we could start with the basics.
Yeah, just go ahead, and you got all the time in the world. Just
okay.
Go for it.
All right. So the bacteria are very common in the environment, including in our drinking water. Drinking water disinfection does not eliminate Legionella for a number of reasons, which we can get into more detail later.
Yes.
In addition, they tend to grow in the drinking water distribution system in the biofilm, and they can be released as a slug with activities like water main breaks or pressure surges, those type of things. They enter buildings through the drinking water and get into the building plumbing. And this is the water that goes to your kitchen, your shower, if there's a decorative fountain or any other water-based equipment that may be in the building.
Okay. Dr. Edwards, now Legionella causes at least two different diseases that we're aware of. One is Legionnaire's disease and one is Pontiac fever. What are these?
Well, those are the two manifestations of being exposed to Legionella while being somewhat immunocompromised. In general, normal, healthy adults are exposed, and for the most part, our bodies are capable of fighting off the disease. But if you are immunocompromised or you're exposed to very high levels of these microorganisms, you could have this Pontiac fever or Legionnaire's disease, which is a type of pneumonia. And the results can be quite serious. It's not uncommon that people die.
Yeah. And what's the difference between the two?
The Pontiac fever is really just a very mild form of the disease, and if your immune system is strong enough, it's generally the manifestation you'll get in, for example, young children.
Mm-hmm. Now, Legionnaires, of course, most of us that are old enough to remember, was first recognized in 1976 in Philadelphia, and it was a major thing back then. What about prior to 1976? What did we know about infections with Legionella?
Well, back in the day, people were, in fact, being exposed, getting sick or dying from it, but we just assumed that it was the flu.
Sure.
And it's only recent that we've been able to identify the cause of this particular type of pneumonia and diagnose it. So there's an appearance that the incidence of this is increasing. And in fact, that might be true. But the reality is we didn't even know that this bacteria was causing or was the specific cause of these pneumonia deaths and disease that were occurring undoubtedly before 1976.
Okay, now Sarah kind of covered how people get infected, but can you go over a little bit more detail of how people get infected and what are the signs and symptoms of Legionnaire's disease?
Sure. People get infected by breathing too much Legionella into their lungs. And the typical routes of exposure are what's called aerosols. These are little tiny droplets of water, and those might occur outside if Legionella is on rain, for example, or it could be in your shower, could be washing your hands, could be your downstream of a cooling tower. There's all different, water irrigation. There's all different ways that these little droplets of water are produced. But if you do breathe those into your lungs, you can get sick, and then it's essentially like a very, very severe type of the flu, type of the pneumonia. And so those are the symptoms, and we're getting a whole lot better in terms of diagnosing it. And back in the day, if you do diagnose it, you can generally treat it effectively, but up until the last few years, that was kind of the exception, not the rule.
Right. Now, you mentioned people that are immunocompromised. So the people that are at highest risk is, in what we see in the news reports, is usually those that are older. Am I right?
Correct. Elderly, smokers, obesity, all of these categories of immunocompromised that are expanding or exploding in our population. This is one reason we think that the incidence might be increasing, because as a whole our population is immunocompromised. We do have these risk factors increasing that make us more susceptible to this disease.
Sure. Now, you mentioned a little bit about diagnosis and treatment. How is a patient diagnosed with Legionnaire's disease today, and how is it treated?
They actually can culture for the bacteria and identify it specifically as Legionella as the cause now. So if you have the symptoms and there's a possible exposure, we can actually identify that bacteria in your lungs. At that point, it's clear what the cause is. Then the next step is to try to figure out how to save the patient, and then also figure out where it came from, which is difficult because Legionella could be contracted in the environment. It could be contracted from all different types of sources.
Now, I was looking at the CDC website, and they report some 5,000 cases annually. Are they lowballing it?
No, I wouldn't say they're lowballing it. Everyone acknowledges that is a lower bound to what actually occurs. As we get better in terms of diagnosing it, that number will tend to go up. But, it's a very serious illness, and it's one we're quite concerned about. And I think the thing that makes it especially concerning is that you can contract this in your shower. And, of course, basic hygiene is so essential to good public health. If we don't, shower and bathe effectively, you can get really, really sick from other bad types of bacteria. So we really do need to do a whole lot better of controlling this in our plumbing systems. And please realize that even though it was 76 that we discovered Legionella, that it was only about 10 years ago that people started taking seriously the idea it could grow in plumbing systems. Up until that time, people discounted the idea you could contract this from drinking water. And, of course, now there's no disputing that it can come from drinking water, it can come from showers, and that as a society we need to do a better job of protecting people from this risk. And part of the issue is that people have to take the bulk of the initiative themselves in terms of the plumbing system, adjusting the temperature high enough to kill Legionella. But there is a role for the water industry and the EPA to play as well. If they can get good chlorine residuals, that can really help reduce the incidence of disease. And as we saw in Flint, Michigan, if that chlorine residual isn't getting to buildings and homes, you can have a major outbreak. And
Sure.
They had 12 deaths that everyone involved thinks is due to the operation of the water distribution system.
Now, let me get one more question into you before I move on to Sarah. The CDC also says, I think it's from the year 2000 to, I don't know, a decade or maybe 15 years later, Legionella cases increased by 286%. Is that just because physicians are better at recognizing it, or is there actually, that much more of it today, or is testing better today? What are your thoughts on that?
There's no doubt that we're getting better at identifying, testing it, but there is concern that its incidence is increasing because of more immunocompromised people in the population, but also our plumbing systems, how we're operating those are changing. For example, the EPA recommended a few years back that they should lower temperatures to prevent scalding, and while that's a good goal, that actually might increase the incidence of Legionella. We also are concerned in many of our newer green buildings where water is sitting around for long periods of time that Legionella is going to be growing in those new buildings. And then, of course, we've got the problems with old infrastructure like Flint's, where you have a lot of old, rusty iron mains, and Legionella just like to grow in that kind of environment. So we do have some reason to fear that the incidence is actually getting worse, but it's quite likely the bulk of the increase is just due to improved diagnosis and detection.
Yeah. All right, Sarah, thank you for being so patient, ma'am. Mm-hmm. Okay. So what can be done for prevention?
There is a lot more that can be done for prevention across a number of levels. If we talk about starting at the distribution system, the EPA could include Legionella on their unregulated contaminant monitoring rule. Legionella was included initially, and that's up for discussion, or it's being finalized right now. It was included, and then it was removed, and now state health departments are calling on the EPA to include it in the final selection for contaminants in the UCMR4, which is coming up. Another thing which Dr. Edwards alluded to was increasing disinfection. A number of jurisdictions reduced the amount of disinfectant because of concerns over disinfection byproducts, and that could have the unintended consequence of maybe not controlling the Legionella well enough in the system. And there's other pathogens in the water as well. Along the same lines with disinfection, right now most states only regulate it as it's leaving the water treatment plant, and we would ask them to ensure the quality of the water all the way through the distribution system. So it's not enough to just have a good residual of disinfectant as it leaves the plant. It still needs to be in the water as it enters the buildings. Yeah. Infrastructure. 44% of our water infrastructure, according to AWWA, which is the American Water Works Association, is in poor or very poor or end-of-life condition. And certainly that leads to water main breaks and those type of things. And we know that those events are linked to releases of Legionella from the biofilm, which grows on the pipe walls, into the water, where it can then flow downstream into the buildings that happen to be downstream. Another thing that the water providers could do is to monitor water age. There was a case in New Jersey. It was a community outbreak, so it wasn't localized on any one building. And initially they looked for cooling towers and couldn't find any, so they had to dig a little deeper. And they did find that there was a water holding tank that was somewhat stagnant, so the water wasn't flowing through it very quickly. It wasn't being used very quickly. What happens then is that the disinfectant residual gets used up, and then the bacteria can start growing. So they found that in the water tank and in the mains feeding a number of streets, which all of the cases happen to be living on those streets. And once they implemented a flushing program to keep the water moving through those pipes, then they were able to hold the disinfectant residual where it should be. So that's something, those are things that can be done at the government level, the state level, the water supplier level.
Okay.
The other thing that they could do is notify people. You know, sometimes you'll see boil water alerts if there's a known issue with the water. If there's disruptions, water breaks, maintenance, scheduled maintenance, they could notify the building facility managers downstream of those events, so those managers can be prepared to take in water which may potentially be compromised. As long as we're talking about facility managers, there's a whole host of things that can happen within buildings to prevent transmission from the water to the people.
All right, Sarah, let me just interrupt for a second. I got about a minute left. So
okay.
Okay.
ASHRAE published Standard 188, which is some guidance to facility managers on maintaining their water system. I'd encourage your listeners to check out the CDC toolkit. Just Google CDC Legionella, and you'll find the toolkit, and it goes through how to develop water management plans for maintaining the water quality within a building, which is extremely important. Turning up your water heater. Do not try to save energy by turning your water heater down. 140 is a good temperature. Things like low-flow fixtures also increase water age and have been linked to increases in Legionella within the piping, specifically in large buildings. And the last thing I would ask is that the CDC could use outbreak investigations as learning tools and really do a complete survey when investigating outbreaks, meaning even if it's an environmental a widely distributed environmental outbreak, to check the water supplies, because if it's in the water, it will go to many buildings and can colonize